Hey everyone, and welcome back to the channel. Today we're talking about something invisible yet absolutely essential for life on Earth, the ozone layer. Think of it as our planet's very own giant, invisible pair of sunglasses. It's this thin, delicate shield high up in our atmosphere, and without it, life as we know it simply wouldn't exist. But what exactly is it? Why is it so important? And what's the story behind that famous hole in the ozone layer? We're going to dive deep into all of that, from its discovery to the incredible global effort to save it. It's a story of science, cooperation, and hope. So, let's get started. First things first, what is ozone? Ozone is a molecule made up of 3 oxygen atoms, written as O3. Now, the oxygen we breathe is O2, with just 2 atoms. That extra oxygen atom makes ozone a bit of a superhero. It's highly reactive and, depending on where it is, it can be a friend or a foe. Down here at ground level, ozone is actually a pollutant, a key ingredient of smog that can be harmful to our health. But way up in the stratosphere, about 10 to 50 kilometers above the Earth's surface, ozone is a lifesaver. This is where we find the ozone layer. Now, don't imagine a thick, solid blanket. The ozone layer is actually a very diffuse region where ozone molecules are more concentrated than anywhere else. If you could take all the ozone from the stratosphere and bring it down to the Earth's surface, it would form a layer only about 3 millimeters thick, that is, about the thickness of 2 coins stacked together. It's incredibly thin, yet it performs a monumental task. The ozone layer is our primary defense against the sun's most harmful ultraviolet radiation, specifically UVB and UVC rays. Think about it like this. The sun is constantly sending out energy in the form of radiation. Some of it is visible light, some is infrared heat, and some is ultraviolet light. UV rays reach the surface and are responsible for tanning our skin, but they're less harmful. UVB and UVC, however, are the really dangerous ones. They carry so much energy that they can damage the DNA in living cells. This can lead to skin cancer and cataracts in humans, harm agricultural crops, and disrupt marine ecosystems by killing off phytoplankton, which are the very base of the ocean food chain. The ozone layer acts as a filter, absorbing about 98% of this dangerous UV radiation before it can ever reach us. It's a silent guardian, protecting every living thing on the planet. So, how does it work? It's a continuous, natural cycle. High in the stratosphere, high-energy UVC light from the sun strikes regular oxygen molecules, O2, and splits them into 2 separate oxygen atoms. These individual atoms are highly reactive and quickly bond with other O2 molecules to form ozone O3. This is ozone creation. Then, when an ozone molecule, O3, absorbs the slightly less energetic UVB radiation, it splits apart back into an O2 molecule and a single oxygen atom. This is ozone destruction. This cycle of creation and destruction is constantly happening, and in the process, the harmful UV energy is absorbed and converted into heat. This beautiful, natural balance kept the ozone layer stable for millions of years, protecting life on Earth as it evolved. But in the 20th century, we humans started to mess with that balance. In the late 1920s, a new class of chemicals was invented, chlorofluorocarbons, or CFC. You might know them by their trade name, Freon. They were hailed as miracle chemicals. They were non-toxic, non-flammable, and incredibly stable, which made them perfect for use in refrigerators, air conditioners, aerosol spray cans, and industrial cleaning solvents. They were everywhere. For decades, nobody suspected they could cause any harm. Because they were so stable, they didn't break down in the lower atmosphere. Instead, they would slowly drift upwards, eventually reaching the stratosphere. And that's where the problem begins. Once CFCs get up into the stratosphere, they are exposed to that intense UV radiation. The UV light that the ozone layer normally blocks breaks the CFC molecules apart, releasing chlorine atoms. And a single chlorine atom is a catastrophe for ozone. It acts as a catalyst, meaning it can destroy ozone molecules without being used up itself. Here's how it happens. A chlorine atom steals one oxygen atom from an ozone molecule, forming chlorine monoxide and leaving behind a regular O2 molecule. Then a free oxygen atom comes along and breaks up the chlorine monoxide, releasing the chlorine atom, which is then free to go and destroy another ozone molecule. A single chlorine atom can stay in the stratosphere for up to a century, destroying over 100,000 ozone molecules during its lifetime. It was in 1974 that two chemists, Mario Molina and Sherwood Rowland, first published their research proposing this theory. At the time, their findings were highly controversial. The chemical industry, which produced billions of dollars worth of CFCs, pushed back hard. But the science was sound. Then, in 1985, the world received a shocking confirmation. Scientists from the British Antarctic Survey discovered a massive seasonal depletion of the ozone layer over Antarctica. What the media quickly dubbed the ozone hole. This wasn't just a slight thinning, it was a dramatic drop in ozone concentrations, sometimes by as much as 60%. Why over Antarctica? The unique and extremely cold conditions of the Antarctic winter create something called polar stratospheric clouds. These ice clouds provide the perfect surface for chemical reactions that convert inactive chlorine compounds into their highly reactive, ozone-destroying forms. When the sun returns in the spring, it provides the energy to kickstart this rapid destruction, creating the hole. The discovery of the ozone hole was a wake-up call for the entire world. It was tangible, frightening proof that human activities could have a catastrophic impact on a global scale. The global response was unprecedented. Faced with a clear and present environmental danger, the world came together. In 1987, just 2 years after the hole was discovered. Countries from around the globe signed the Montreal Protocol on substances that deplete the ozone layer. This landmark international treaty was designed to phase out the production and use of CFCs and other ozone-depleting substances. It was a monumental achievement in international diplomacy and environmental protection. The treaty set a clear schedule for developed and developing countries to reduce and eventually eliminate these harmful chemicals. And the amazing thing is, it worked. The Montreal Protocol is widely considered the most successful environmental agreement in history. Because of it, nearly 99% of ozone-depleting substances have been phased out globally. We stopped manufacturing CFCs and replaced them with less harmful alternatives like hydrochlorofluorobonds or HCFCs and later hydrofluorocarbons or HFCs. Now, it's not a perfect solution, as some of these replacements are potent greenhouse gases, and the world is now working to phase those down as well under the Kigali Amendment to the Montreal Protocol. But in terms of saving the ozone layer, the results have been incredible. So, what's the status of the ozone layer today? The news is overwhelmingly positive. Scientists have confirmed that the ozone layer is slowly healing. The ozone hole over Antarctica still forms every spring, but it's generally smaller and less severe than it was at its peak in the early 2000s. Models predict that the ozone layer over the mid-latitudes could recover to 1980 levels by around 2040, and the Antarctic ozone hole is expected to close by around 2066. This is a huge success story. It shows that when we listen to science and act collectively, we can solve major global environmental problems. The healing of the ozone layer has had huge benefits. It's estimated that the Montreal Protocol will have prevented 2 million cases of skin cancer per year by 2030, along with millions of cases of cataracts. It has protected our agriculture and ecosystems. And because many ozone-depleting substances are also powerful greenhouse gases, phasing them out has had a significant positive impact on climate change, avoiding a substantial amount of global warming. The story of the ozone layer is a powerful lesson for us today as we face the even greater challenge of climate change. It shows us that global environmental threats are real. It proves that human activity can drastically alter our planet's systems. But most importantly, it gives us a blueprint for success. It demonstrates that with scientific understanding, international cooperation, and decisive political action, we can come together to protect our shared home. It's a story of resilience both of the planet and of humanity. It's a reminder that we are not powerless and that our actions, when guided by science and a sense of shared responsibility, can make a world of difference. Thank you so much for watching. The ozone story is one of my favorite examples of how we can get things right. If you found this video interesting, please give it a thumbs up, and don't forget to subscribe for more deep dives into science and our amazing world. Let me know in the comments what you think. Until next time, stay curious.